Random access protocols are another class of multiple access protocols. In random access protocols, when a node has packets to send, it transmits them at full channel data rate, which we define as R. It neither does coordinate with other nodes, nor it uses a pre-assigned time slot, frequency, code, or any type of assignment. So, as you may have guessed, this may cause collisions. When two or more nodes transmit at the same time, collisions happen. In case of collision, each of the sending nodes waits for a certain amount of time, then it retransmits the packet. The retransmit also happens at the full channel rate. A random access MAC protocol determines how to detect collisions. The senders should know when the collision has happened in order to be able to retransmit. The random access MAC protocol also needs to define the procedures to recover from the collision and transmit a packet correctly. Examples of random access protocols that we will briefly discuss include Slotted Aloha, Aloha, CSMA, CSMA-CD, and CSMA-CA. Aloha is one of the oldest and one of the simplest random access protocols. We will discuss Slotted Aloha as well as Pure Aloha. Let's start with the Slotted Aloha. In our discussions, we are going to assume the following. All data frames have the same size. We divide time into equal size time slots, which is the amount of time needed to transmit a one frame of fixed size. Nodes only start to transmit at the beginning of those time slots. Nodes are synchronized. This means that all of them have the same perception of time and when each time slot happens. If two or more nodes transmit on the same time slot, all nodes, including those sending, are able to detect the collision. With this setting, when a node has a fresh frame to send, it will use the immediate next time slot to send it. It will wait until the beginning of that next time slot and use the full channel capacity to send out the frame. Now, if there is no collision, the transmission has been successful. A node can move on to preparing the next frame if it has more to send. If there was a collision though, the node detects the collision in the same time slot. It knows transmission has failed. In the event of failure, the node transmits with probability P in each of the upcoming time slots. Using the probability for each time slot is like tossing a coin for each time slot. So think of it as in each upcoming time slot, the node will send if node gets a heads in a coin toss. If it gets tail, it will toss the coin again in the next time slot. This process is repeated until there is a successful transmission without a collision in one of the attempts. The figure shows a simple slotted Aloha example. Under each time slot, the letter C notes collision, E shows an empty time slot, and S shows a successful transmission. In the initial time slot, nodes 1, 2, and 3 transmit together. All sense collision and know they have failed in transmission. The next time slot, neither gets the probability to send. On the third time slot, 1 and 2 attempt again, and collide again, and fail again. On time slot 4, 2 attempts again, and this time it succeeds. The next time slot is also empty, due to probabilities. On the sixth time slot, 1 and 3 both send again, and collision happens again. Time slot 7 is empty again, showing the probability was to not transmit on either of the nodes. And on the time slot 8, node 1 transmits again and succeeds. And on time slot 9, node 3 transmits and succeeds. Unlike channel partitioning that limits the user to a specific portion, slotted aloha allows a user that has packet to send to continuously send packets at the full rate of the channel. And the transmits will be successful if there is no other user sending at the same time. Slotted aloha is also a highly decentralized protocol. There is no coordination among the nodes. The only thing shared is the timing of the beginning of the time slots. It is also a very simple protocol. However, as you can see in our example, collisions may happen more than once. And the time slot in which a collision has happened is basically a waste of time. Also, some time slots might be empty even though nodes have traffic to send. Nodes need to detect collision. Sensing the collision might take even more time than sending a packet, and this adds to the inefficiency of the mechanism. And even though synchronization is minimal, it is not easy to achieve.